Okay, so for this tutorial, we're going to go over how to do some surface modeling in Rhino 3D. So we'll go over a couple things, starting with how to create different types of curves, and then convert those curves into surfaces using different types of commands like loft, extrude, revolve, sweep 1, and sweep 2. And then we'll go over some surface editing tools like rebuilding, offsetting, and then we'll get into some drawing techniques like Make 2D, so you guys can render out and output an image that looks something like this. Right, we have just a basic rendering underneath and some line work that explains the curvature of the surface on top. So let's hop in. So the first thing we're going to go over is how to create curves in Rhino and the different types of curves that exist. There's really two different ways to create surfaces in Rhino. One is through setting up a series of curves and using commands that convert the curve into a surface. The other way is more freeform, where you start with sort of a flat plane surface or some sort of platonic piece of geometry, and you kind of manipulating it using control points. We're going to get into the freeform stuff a little later. For now, let's start with using curves and converting those into surfaces. So before we do anything, I just want to review the different types of curves you can create in Rhino. There are single lines, which is just your line command. There are polylines, which are single lines that are straight. You can do arcs. You can do polylines that have arcs within them. So you'll notice this has a straight line and then an arc and then a straight line, and then it has a kink. And then you can do splines, which are more freeform like curves. Now, there's a really important difference to understand between each one of these types of curves, and that's what's called the degree of the curve. So there are 3 degrees of curvature in Rhino. 1 degree is just a straight line, okay, from point A to point B. There's no curvature in this. A polyline is also considered a 1 degree curve because it's just a series of straight lines. When you get into arcs, this is going to be a 2 degree curve, similar to arcs with a polyline. So if you fillet corners, that's also 2 degree. And then a spline is a 3 degree curve. So what's the difference? Well, between a 1 degree curve and a 2 degree curve, obviously you start to get some actual curvature. But what's the difference between this and this? You'll notice when you select a curve, it turns on what are called control points, which are these little points here. You can also toggle them using F10 on your keyboard. But in Rhino 6, they kind of just turn on automatically when you select your curve. What you'll notice, the difference between a 2 degree curve and a 3 degree curve is whether or not that curve can kink. What I mean by that is it has a hard corner here, okay? So an arc, even though there's no kinks, if I select this and then I select this middle control point and I push this down using my gumball, you'll notice that it actually does have a kink in it. It's just when the curve is in its arc form, you don't notice it. So just to recap, 1 degree, no curvature. 2 degrees is curvature, but you have kinks, whether it's between 2 polylines or 2 lines, or it's a kink within an arc where one curve starts and one curve ends and one begins. Or you have splines, which is no kinks. It's a completely fluid line, which means I can take these control points and push and pull them as needed. Okay, and you'll notice there are no kinks in that curve. Okay, so how do you transition between 1 degree, 2 degree, and 3 degree curves? Well, it's called rebuild. So if I take this polyline curve and I copy it over and I select it and type rebuild, it's going to ask me for a point count and a degree. So the degree is where you can switch between 1, 2, and 3 degree curves. Okay. Again, 1 is going to maintain that sort of faceted polyline-like line. 2 is going to give you that curved line, but you're going to have kinks in it. And 3 will convert that polyline to a spline. Your point count is just the density. So if I lower this down to like 2, it's going to be a straight line because I only have 2 points, 1 at either end. Notice it also forces it to be a degree of 1. But if I up this to say 4, you're going to start to notice that as I make it higher, that curve is going to match that polyline as best it can. So I can make this like 200, and it's going to almost match that polyline perfectly, and you're going to get some rounded over points at the corner. Okay, you typically wouldn't ever do this. The point of rebuilding a curve is to convert yourself from a polyline to an arc or to a spline. So you'll always want to leave this relatively low. Okay, and you start to get these types of curves. So you can click OK, and now that curve, that polyline, which was degree 1, has now converted to a degree 3. And I can start to mess around with this as if it were a spline. Okay, so that's just a brief overview of curves. Now, why is that important? Well, one, it allows you to change the sort of aesthetic value of your curve that you're working with. The other thing that it changes is the way that that curve produces a surface. So over here, I've created, or I've extruded each one of these curves into a surface. And I want to review the differences between extruding a 1 degree curve versus a 3 degree curve. So all I've done is I've copied these over, and you can type extrude curve, extrude CRV, hit enter. That's going to allow you to just extrude these up. You can type in a distance of 10 feet if you'd like. I think this is only like a foot. And then hit enter, and it's going to extrude those curves upwards. Okay. When you extrude a curve into a surface, you're going to get 2 different types of surfaces. One is just a surface, and the other is a poly surface. It's really important to understand the difference between the two. A surface is just a single surface. Okay. It's one curved plane or warped plane, and it's not comprised of multiple surfaces. But you'll notice when I extrude this polyline, or this arc and polyline, okay, I've got multiple surfaces shown with these dark lines here. Okay, basically each one of those lines pops up wherever there's a kink in your curvature or in your line. So I can actually select these 2 surfaces, type explode, hit enter, and it's going to explode those 2 poly surfaces into 12 individual selectable surfaces. Okay. One isn't necessarily better or worse than the other. It depends on the look that you're going for and the type of geometry that you want to create. But just understand that when you have a kink in a curve or in a line, that it's going to result in a poly surface. One thing to remember when you hop in the Grasshopper poly surfaces and surfaces react very differently in Grasshopper, so just understand that there are two different options that you can go with. I'm just going to join these back together, select it, type join, and hit enter, and it'll join everything back into a solid or single poly surface. Okay, so those are the different types of curves that you can create, and these are the different types of surfaces that you can create. So degree, and then surface versus poly surface. Okay. The next thing we're going to go over real quick are the different types of commands you can use to convert a curve to a surface. The first one I've shown you is extrude. So let's just select a curve and type extrude curve, hit enter, and it'll ask you for a distance to extrude that surface. Okay. So what I've done is I've taken actually this arc curve and I've created 5 different surfaces using 5 different commands. Okay, first one being extrude. The second one is called loft. So what I've done to create this kind of warped surface is I've taken this arc, I've sort of rotated it. So on one side the arc is facing this direction. I'm just going to move this up real quick. Okay, and then I've copied this curve and I just flipped it around. So I'm going to rotate it into the other direction. Okay, I'm going to select both curves, type loft, and what it's going to do is it's going to loft those 2 curves from one curve to the second curve. Okay, and you have a bunch of options over here when this pops up. I usually keep it at normal. You can do loose, tight, straight sections. You're not really going to see a difference here, but if you're doing more complex curves, you might cycle through these just so you can see the change in surface quality that you get. I also typically choose do not simplify. That way the edges of this surface are as accurate as possible and maintain that arc. If you do rebuild, sometimes it won't be able to maintain that edge. So that's what loft does. It creates a surface between 2 curves. You can also do multiple curves. It doesn't have to be limited to 2. So I'll just pull these 2 curves out. And let's say I want to loft 3 curves. So I've got 1, 2, 3. And then I'll type loft and hit enter. And that will give me something like this. So you can loft an infinite amount of curves, so long as that they're kind of in a row. Okay, so that's your loft command. The next command is called revolve. So again, I'll just go back to my arc, copy it over, and then I'll type revolve. Now revolve is going to ask me for a start of a revolve axis, so I'm going to select sort of out here at the center of this arc, click, and then end of revolve axis. So I'm going to click somewhere out here. I'll hold shift so I snap to my x-axis. Then it's going to ask me for a start angle, so I can click on the curve. Then it's going to ask me for a revolve angle. So 180 is going to revolve that curve 180 degrees. Okay, I'm just going to turn off my snap real quick. All right, so 90, 180, 270, 360 will bring it all the way around. Okay, so revolve will take any curve and revolve it around a center point and a direction. Okay, and then you can give it a value of 0 to 360 depending on how far you want it to revolve around that axis point. So again, let's revolve. I'm going to grab the center, and then I'll revolve that 180 degrees. Okay. Sweep requires two curves, so I'm going to take this arc, I'm going to copy it, and then what I'm going to do is I'm going to rotate this once and then rotate it again twice. So this curve is now running perpendicular to the one on the floor. Then what I'm going to do is I'm going to take this curve and I'm just going to rotate it about 45 degrees and then pull it up. Then I'm going to take this curve, I'm going to type move, hit enter. I'm actually going to snap the end of this curve to the midpoint of my arc. Okay. So what sweep 1 is going to do is it's going to take this curve and extrude it along this upper curve. So I'm going to type sweep 1 and hit enter. It's going to ask me to select my rail. Your rail is the curve you're sweeping along, so I'm going to select that. Then it's going to ask to select cross-section curves, which are any curves that are going perpendicular to that rail. So I'll select this, I'll hit enter, and you can see that it's now sweeping this curve along, or sweeping my arc along the rail. Okay, and again, there's a lot of options here that you can choose from and kind of mess around with. I usually keep them at their default, click OK, and now you've got this kind of shell-like structure. Okay. Sweep 2 is similar. So let me go back to my starting arc. Sweep 2 requires two rails. Sweep 1 just had a center rail. Sweep 2 will have two. So I'm going to rotate this. Well, first I'm going to copy it, and then I'll rotate this upper curve. I'm going to rotate this bottom curve just a little bit. And then I'm going to move this curve here, and then copy this curve to the other point. Then I'm going to mirror this curve based on the center of these two arcs. So I have something like this, okay, where I've got four arcs, a front and a back, and then a side and a side. And sweep 2 is going to sweep this curve across to this curve while using this and this as a guide for the edges. So I'm going to type sweep 2, hit enter. It's going to ask me to select my first rail, my second rail, select cross-section curves. I'm going to select the first one, and then I'm going to select the second one and hit enter. And it's going to sweep that curve along the rails back down to this curve. Now I don't need a second curve to create that surface. If I type sweep 2 and hit enter, and I select my first and second rail and then my cross-section curve, if I just select the first one, it's going to default to a different position, right? It's going to sweep that curve until Rhino decides it wants it to end based on the angle, your starting angle and your ending angle. So by adding in this section, this second curve, I've actually given it a defining moment to end. So if I do sweep 2 rails, cross-section curves, well, if I select that second arc, I give it a moment to end, and I have a little bit more control over how that surface is created. Click OK, and it'll create that curve for me. Now, what you'll notice in this instance, for some reason, it created a poly surface, right? Notice this dark edge running across the surface. This means I can select this and type explode, and it's going to explode it into two surfaces. Now, I may not want that, so what I'm going to do is The reason that's happening is because these are technically 2-degree curves, right? If I select this second or this middle control point and I pull these down, see how that kinks? That's why I'm getting a poly surface out of this. So if I want to avoid that, what I can do is select these 2 curves and type rebuild, and I'm going to turn them into 3-degree curves with a point count of 10. That's fine. You can look at your maximum deviation down here to see how much those curves are changing. 0.0005 is almost nothing, so that's okay. It means these curves won't change dramatically when I rebuild them. And then I'll click OK. So now when I do my sweep 2 and I select my rails and then my cross-section curves and hit enter, now that's just one surface. Okay, if I type explode, so it'll say cannot explode single surface. Okay, so that's when it's important to understand the difference between 2-degree and 3-degree curves, because sometimes there's a kink and it's going to result in a poly surface. And in this instance, a poly surface may not be what we want. Instead, we want a nice clean single surface. So we can bring that into Grasshopper and panelize it and do all of those types of things. So those are the sort of 5 main surface commands when you're trying to convert curves to surfaces. Each one of these can be applied to either splines, lines, or arcs. It doesn't really matter. Just gotta bring my arc back. So you'll have to experiment with how each surface command reacts to different kinds of curves. So the next thing we're going to jump into is rebuilding surfaces. Okay, so what you'll notice here is I've taken each one of these surfaces and I've rebuilt them using different values. Now, rebuilding a surface is very similar to rebuilding a curve. The difference is when you rebuild a surface, you're rebuilding it in 2 directions instead of 1 direction on a curve, which means if I select this surface and I type rebuild, it's going to ask me for a point count, which is my density of points that create this surface, and it's going to ask me for my degree. Now you'll notice the degree and point count in a curve, if I rebuild a curve, right, I only have one option for my point count and my degree. If I rebuild a surface, I've got 2 options. Okay, it's broken them out into U and V. U and V are directions across your surface. Okay, so my V direction might be from front to back, and my U direction might be from side to side or left to right. The point count, again, that's your density, so you can make this really dense. If I want to up it to 100 and 100, I can click preview. That's going to be a really dense surface. You would never want to do that. You always want to keep it really as low as possible. So I'm going to put this down to 10 and 10. Okay. And my degree, I'm going to set these to 3 and 3. That means I'm going to have a smooth surface all the way across. Okay. So I'll click OK. And now I've got a really nice smooth surface. Now that didn't really change much from the previous version, right? All it did was it made this surface a little denser. That can sometimes help you in Grasshopper. There isn't really a huge need to do that though. If a lower poly count or a lower point density gives you the surface that you're looking for, you should always keep it low. What will change though is if I select this and I click rebuild, if I start putting these down to 1 and 1, okay, that's going to give me a faceted surface, right? Because now my degree is 1, so I'm getting straight edges. Okay, so that's a really good paneling technique if you want to convert a surface into sort of panels. You can rebuild it at 1 and 1 and give it different kinds of densities. So let's say I make this 10 and 3. Okay, now I'm going to get a really faceted surface. All right, or 10 and 5. Okay, now I've got an even more faceted surface. So you can go through and see what happens when you rebuild with different degree values at U and V. So 1 and 1 is going to give you faceted edges in 2 directions. Okay. If you do 3 and 1, it'll be faceted in 1 direction. So you'll notice it's faceted from front to back. And then it'll be smooth in the other direction. So you'll notice I get a nice smooth arc. Okay, so just a slightly different aesthetic look to that type of surface. And then again, 3 and 3, not much difference, just a slightly more dense model for that surface. Okay, so that's rebuilding surfaces, and you can use that to your advantage to create faceted or smoothened surfaces. The next thing I'm going to go over is how to provide thickness for your surfaces. This says offset mesh, but it should be offset surface. That's the command we'll be using. You'll notice that these are all now shelled, so they actually have some level of thickness to them. These surfaces here without thickness, these are what are considered impossible surfaces. They only exist inside Rhino. You can't 3D print this because it has no thickness to it. It has no material value. So if you want to be able to 3D print something like this, you have to give it thickness, which means it now has volume to it. So the command to do that is called offset surface. So I'm going to just copy this over. I will type offset surface, which is offset SRF. And it's going to ask us to input a bunch of information. First of all, it wants a distance. Okay, so I'm going to set it to 0.25, whatever units I'm in. Solid, yes. That means it's going to create these walls when it offsets the surface. Loose, I typically just leave that as no. You guys can mess around with that option if you'd like to. Both sides means it'll offset it in 2 directions. You can do that if you want. I usually leave that off just so it goes in 1 direction. And then you have this flip all option, and that's going to determine the direction in which the surface offsets. So right now you'll notice all these white arrows are pointing inwards, so that surface is going to offset inwards. So if I hit enter, it just thickened that surface and offsets in and offset it inwards. If I do this command again, offset surface, and I click flip all, it's going to reverse the direction of those arrows. I hit enter and it just offset that surface outwards. Okay. Offset surface command will work on both poly surfaces and regular surfaces. So I can select this poly surface, type offset surface. It's going to ask all the same questions. I'll hit enter and it will give that surface some thickness. Okay. The only tricky part with offsetting poly surfaces, you want to check your kinks to make sure that that looks okay, and that you don't have any self-intersecting geometry. So once you offset these are now 3D printable. You can export them to any 3D printing machine and have your 3D printer make those. The next thing we're going to go over is how to create the drawing, which is this guy here. So it's just real quick a rendering straight from Rhino's built-in rendering program, and then I've extracted line work using extract wireframe and make 2D commands. So it's pretty straightforward. I'm going to take our thickened surface, copy it over, and then the first thing I'm going to do is select that surface and type extract wireframe and hit enter. And when I do that, I just hide this surface real quick. You'll notice that it created a wireframe of that model, okay, or of that surface, okay, and that's going to help us produce this image where the wireframe is actually helping explain the way that surface revolves or is mapped or is curved, okay. So I've got my wireframe and I've got the surface, the thickened surface, sitting right underneath it. You want these two to align. Don't move them after you've done it, or if you do move them, make sure you select everything at one time and move it so that they move together. Then what you're going to do is first we'll set our camera, or the point of view from which we want to produce the drawing. I like to set my camera to parallel, so this is an axon view. And then what we'll do is we'll select both the wireframe curves and the surface and type make 2D. And what this is going to do is make a 2D drawing of that surface, and while including those wireframe curves. So you want to make sure your tangent edges are on. This will show where curves start and stop. You can kind of see the little preview up here. You want your hidden lines to be on, so you see lines in the background. And you want your scene silhouette to be on as well, which is your border line. Okay. Before I click OK, though, what we want to do is save our view. Okay, so I want to pick a view. I want to type named view, hit enter. I've already saved one. You can click the little save as icon up here. That's really important because you want your make 2D viewpoint to match your rendered viewpoint. And if you don't save your view, the minute you pan or switch the view or rotate or anything like that, you're going to lose that view and you'll never get it back no matter how hard you try. So always, always, always save your view. So I'm going to save it. I saved it as axon 1. When you want to return to that view, you just type named view, double click axon 1 or whatever view you want to go to, and it'll jump you back to that view. So I'm going to set myself there. I'll then select the surface and those curves, type make 2D, make sure these are checked, click OK. Now, what that's done, if you switch to your top view, it's taken those wireframe curves as well as the curves of that surface and converted them into a 2D image that has 3 line types, okay? And it's layered them for you. So you've got hidden lines, which are in the back. You've got your visible lines, which are in the front. And then you've got a scene silhouette, which are the lines that go around the border. So you can, so what I've done is I've just created that and I've moved it over here. Okay. Now the nice thing about this is you can select these curves, type export, and you can save them as an Adobe Illustrator file. So that's what I've done here. I've saved my line work as an adobe.ai file. And so once you do that, when you open up your line work file, it's going to give you something like this. There's a couple options that you can change or mess around with when you export your curves. So if I select these, type export, select Adobe Illustrator, line work, You can do snapshot of current view, which is what I typically do if I'm not worried about the scale of the drawing. If you do want to scale, you have this option, and you kind of have to do some math to figure it out, but that's how you would scale your drawing. Color RGB is fine, doesn't really matter. Export viewport boundary, I never really do that. I always end up creating my own boundary for the drawing. If you're doing hatches, you may want to check this. Sometimes Illustrator doesn't know how to read hatches from Rhino because they're not built into Illustrator's software. So checking this may help, it may not. Sometimes what you have to do is explode your hatches before you export them as an Illustrator file, so they show up as curves instead of hatches, and then you just put them on their own layer. And then you can click OK, and it will export out your Adobe Illustrator file. So what you'll get is something like this. And the great thing about exporting as an AI file out of Rhino is that it's going to maintain all of your layers in your curves. So all I did to get from here to here is I've just rechanged the size of the artboard, and then I've brought in a rendered image, which we'll go over in a sec. But I've basically just changed the line types of each of these layers. So your scene silhouette gets the heaviest line work or line weight. Your visible curves are somewhere in the middle, and your hidden curves are your lightest line. And then I just created this border around the outside. Now for the rendering in the background, what you want to do is switch back to your named view. Okay, and switch yourself to rendered mode. And I'll just hide these curves. And I've just given this surface some material. So if you can select it, go into your properties tab, go into material. I just applied a Rhino material of paint. You can create new materials. There's glass, metal, paint, picture, plaster, plastic. You can mess around with these. I think paint shows the best curvature in terms of like highlights and shadows. So usually what I do is I set it to paint. I'll give it a color, and then I'll take the glossiness and I'll just kind of turn it down a little bit so it's not so glossy. I mean, it's up to you if you want to keep it that way or not. I just think turning it down makes it a little easier to read and understand. And that's about it. And then you can select the surface, right click on your material, and do assign to objects. Okay. Then you need to just render it out. So you go to your rendering tab. I usually just keep the resolution, but you can change that if you want. DPI you can set to 150, quality good. Again, you can raise those if you want a better quality image. It's just going to take longer to render. Usually turn off the ground plane. I don't want to see any shadows or anything like that. This thing to feel like it's floating. So I'll turn off ground plane. Sun settings. I turn on the sun so you get that little bit of shadow. And you can click on sun settings to open up where the sun is located and where it's pointed. I usually just turn on manual control and mess around with these until I've got kind of a nice shadow effect on one side. And again, it's just about kind of providing the reflections and the depth needed to show that this thing is actually curving. You don't want it to read as a flat, flat image or a flat area. So just click OK. And then everything else you can leave the same. There is this render curves option under wireframe. I never use that. It doesn't look good, and you can't change the line weights afterwards. So that's why I do the extract wireframe instead, because it gives me the line work and the ability to change the line weights. So I know it sounds like that's a nice tool, but I would stay away from that. And then you can come down here and just click render. And this will take just a couple seconds to render out that image. Okay, once it's done, just do save as. And I usually do PNGs so that there's no background in the image, so you don't have to crop anything. Or you can do JPEG if you know you want your background to be white. And then that'll give you your rendered image. And then in Illustrator, just place that image in the back, so I'll put it on the lowest layer on its own layer. And then you just have to resize it to match the line work. And that takes a little bit of time, but it's not too bad. Just want to make sure your edges are all right. You don't want it to end up something like this, where it's offset or not quite matched. You don't want to see any white space between your line work and your image. And then you can export this out as a JPEG. And that's sort of like the really quick and easy way to generate a drawing of a complex surface. The last thing I'm going to go through for this tutorial, I'm just going to switch myself back to perspective. Is more free-form modeling. Okay, so you would do this before you thicken your surface. So if I just have an open surface, something like this, okay, I'm going to pull this over, and I've already started to kind of modify it. Any single surface, okay, not poly surfaces, this won't work for a poly surface, but for any single surface, you can select it and hit F10 on your keyboard, and it's going to turn on control points for that surface. And what you can do is you can select these control points, and you can adjust them and move them around. So I can pull these down, and it's going to modify the way that surface looks. Okay. This is basically how freeform modeling in Rhino works, is to turn on your control points, and you can do some really nice freeform surfaces that have, you know, custom curvature or, you know, anything like that, and it doesn't require you to figure out how to do or how to set up all of the curves required to produce these kinds of effects. Okay, I don't recommend working like this in Rhino until you get really familiar with how surfaces react to different environments and different effects based on the curves that you input them. So spend some time using these commands to produce surfaces before you get into, you know, freeform modeling like that. One major reason is because Rhino can be very fabrication oriented, meaning that, you know, information found in Rhino can be directly used for the fabrication of these surfaces, whether it's 3D printing, laser cutting, whatever. When you produce a surface based on a curve, it's a measurable surface, meaning this curve has a diameter or radius to the arc. This spline has certain diameters or radiuses to different moments on this curve. You know, that fillet has a radius, that straight segment has a distance. So when you produce surfaces based on those curves, you can measure that surface using different techniques. When you get into freeform modeling, there's not really any way to measure this surface anymore because it's no longer based on a two-dimensional curve. It's based on three-dimensional points in space. So you're far more limited in terms of extracting information for fabrication. At this point, you would only be able to really 3D print this or surface mill it using a CNC machine. So just kind of be aware of that while freeform modeling, it kind of gives you a much more open-ended way of modeling. You tend to lose a lot of control over how the surface looks and reacts. So it just takes some time to kind of get used to that method of modeling. And again, that only works for single surfaces. So if I go to a poly surface, one of these guys over here, and I hit F10, it's going to tell me cannot turn on control points for poly surfaces. Okay, and that's just because it's the nature of the modeling software. It just doesn't really work out that way. Couple commands to avoid when surface modeling, and this is more for when you're getting into Grasshopper. Try not to use the patch command. Grasshopper doesn't read patches very well. And then also try and avoid trim commands. Try not to trim surfaces. So for example, if I wanted to create this opening here, I wouldn't create a dome and then trim that out with a curve. Okay, again, this is a Grasshopper thing. Grasshopper won't be able to read that trim. But if you revolve it, and this surface is based on an arc that's being revolved around a center point, Grasshopper will be able to read that edge. So again, avoid patch and trim commands. The last thing I'm going to go over is the difference between a NURB surface and a mesh. And this is going to get into 3D printing a little bit and prepping a model for 3D printing. All of these surfaces that we've created are what are called NURBS surfaces. A NURB surface is a type of surface that is native only to Rhino 3D. It is a surface that is inherently curved. It looks like it's curved, and it's based on point density and the curves used to generate that surface. I say that it only exists in Rhino because the minute you take this into another piece of software for 3D printing, let's say, you're going to convert this surface to a mesh. That always happens. And so let's just kind of review the difference between a NURB surface and a mesh. So I'm going to take this surface and pull it out, and then I'm going to copy it so I have two side by side. So this is our NURBS, and we're going to convert this surface to a mesh. Okay, so I'm going to select it, type mesh, hit enter, and you're going to get this little option that comes up. And this basically controls the density of this mesh. So if I hit preview, okay, you're going to notice that my surface is not really dense and it looks faceted. Okay, if I pull this all the way over, when I hit preview, it's going to be really, really dense. So let's look at the difference. So I'm going to click OK, and now I have a nice dense mesh. I can delete the underlying surface. I'm going to copy this again. I'm going to type mesh, hit enter. I'm going to move this all the way down, click OK, delete the surface, and now I'm left with a less dense mesh. Now, when you convert or export a surface out for 3D printing, typically you export it out as a .stl file or a .obj file. When you go through that process, so if I export this and I select obj, that will work for 3D printing. I'll call this 3D print. Desktop, save. It's going to ask for some options, okay? It's going to say polygon mesh objects. That's what we're going to export as. And then under formatting, it's going to go through some options. Most of this stuff you can leave the same as is. Naming, just leave the same. Mesh, that's fine. Click OK. Then it's going to come up with this menu option again, and it's going to ask you how many polygons you want to convert this NURB surface with. And so typically what I do is if I'm going to 3D print something, I convert it to a mesh in Rhino first, just so I can see what it's going to look like. And you want to do that because you want to pay attention to the density of that mesh. When you go to 3D print something, any curvature that you're 3D printing isn't actually curved. It's comprised of a series of faceted faces. The denser that curvature, or the denser that mesh, the smoother it will look. The less dense, the more faceted it's going to look. So you want to make sure that when you're exporting out your models or your NURB surfaces from Rhino for 3D printing, that you're getting a nice high dense mesh. Okay, so that you've got some nice clean curvature for 3D printing. If I switch this to rendered, you'll start to see the difference between the two meshes. Okay, one is really faceted, kind of low resolution. The other one is much cleaner and a much higher resolution. Okay, so I'll switch this back to shaded. And so, you know, if I wanted to come over here and I wanted to 3D print this, I'm going to copy it. I'm going to mesh it, so I'll type mesh, hit enter. I'm going to pull this all the way over so I have a nice dense mesh. I'm going to delete the underlying surface because I don't need it anymore. Then I can select this, type export, desktop, and save it as an OBJ or an STL. And that will be 3D printable. Now obviously what you want to do is resize this to fit your 3D printer before you send it. I didn't really scale any of these, so I don't know how big they are. But that would be your first step, is resizing these to fit inside your printer box. And that's it for this tutorial. Thanks.